Hello, and welcome to another episode of BetterTech. My name is Peggy Tsai, where I will be exploring the innovation space between technology and artificial intelligence. So, for today's topic, we will be talking about the dynamics of preparing and modeling data for large language models. So, I'm really excited to have with me today Ethan Ding, who is the co-founder of TextQL. Welcome, Ethan.
Hi, um, good to be here.
Thanks for being here today. First, I thought we could start out with a brief introduction about yourself and also talk about how you became a co-founder of your company.
Yeah, I guess I was like born like very random rural village up in like northern China. Moved around a lot as a kid because my parents were, or my dad was a professor, and so it's like Sweden, Houston, Hong Kong, and then before we were going to study engineering at Berkeley, um, came to New York. Started. I spent the last year of college like working in a VC at Bessemer, and then joined a startup called Tackle, where I worked on the data team for about a year and a half. Grew that to about like 12 people, and then decided. Well, I met a guy. I think my girlfriend said to me, "If you don't start a company right now, you're not like you're not very. If you were brave, then you would start a company right now." So I was like, the market's down. Like, it's probably a really good point to start a company because now you get to like ride the next wave up. And so I met my co-founder Mark. We were like, let's work on like the hardest thing we could possibly imagine, where it's obviously valuable. If we succeed and if we fail, it'll be because of the technology, and that's like entirely our fault. It won't be because we couldn't convince people to want it. So we're like, okay, let's build full self-driving for like data science, right? Like, can we like build the rails on which large language models and AI can like navigate like really really complex enterprise data like data stacks. And so that's where the origin of TextQL really started.
Wow, that's fantastic. And I know that many people are not always as a little bit more risk averse, right? So certainly starting a tech company is really exciting. So love to talk a little bit about that in this podcast and really explore that. But as first of all, I think anyone watching this video immediately will notice this is not a Zoom graphic that's on your head. I thought maybe that could be something you talk about. I think it's also a great analogy to growing growth, trees, plants, organic. So I thought maybe you could just cover that now, get that
Sure. Yeah.
explanation out of the way.
I be a little bit more like candid in like most of my communication. I really don't like hyper professional like business talk. So when I was like setting up my LinkedIn, I was like, oh, like I kind of knew I always wanted to be a founder. So there's a bunch of like gardening metaphors, like being a VC is like watching other people curate plants, and then like joining an early startup is like watching someone else like grow the plant and like helping them as like a support person. And now I'm like growing my own like tree garden. It's actually not super. The origin of this is just I saw a bunch of people with this in their head, and I thought it was really cool. And then my girlfriend bought it for me for Christmas, and I haven't seen her in a while, so I've been wearing this on my head in the meantime because I thought it's like a cute memento of her.
No, that's a great story. So I think that segues hopefully well into really talking about the topics of large language models. I think a lot of organizations are really deep diving into this area, and they may not necessarily have all the right tool sets to scale into the data space. So let's first of all, could you describe the what the modern data stack looks like for organizations, for your target customers, and what role modern data stacks play in today's data landscape?
Yeah, for the most part, like we work with like enterprise companies, like 1,000 employees and up. We've been fairly like horizontal in the sense that we're not like we work with we recently announced our partnership with the NBA, so like sports media, but also like we're working with a telehealth company in like the provider space. We've worked with financial services institutions and money managers, as well as like labor marketplaces and like marketing analytics segments. So like the way all of this, the thing that all these enterprises kind of have in common is like they have these places where data is generated, like their local tools. This could be your Salesforce, your ERP, your EHR platform, your marketing, Google Ads, ad spend, like all of like Slack, even like anything that you use for communications or operations at your company, that's like generating tons of data. And while it's cool to like do some analysis in that data itself, the modern data stack is really how you there's a layer of ingestion that takes that data and copies it into a warehouse where it is stored. On top of the storage layer, you have, and that's for platforms like Snowflake. On top of the storage layer, you have things like DBT or transformation layers, where you model the data in such a way where it like, there's a bunch of different philosophies for data modeling. But so depending on what your data engineering team has chosen, you've modeled the data in accordance, hopefully, with your business needs, and then you can start building internal applications and internal like use cases on top. Right, this is where the data science happens on top of like relatively clean data. This is how you build internal tools like admin dashboards or like control panels for like your internal operators. It's also how you build like dashboards on top of these things. So like BI tools, and across like these like kind of applications that are built on top of the warehouse data, you'll then be able to launch like this is something that hasn't been like very popular in the modern data stack, but it's starting to merge together. It's like RPA, like all like robotic process automation, triggering workflows into the rest of your like organization. So if you like take this end to end, this could be your Coca-Cola, you have like a bunch of like shipments in SAP that is brought in from Fivetran into a warehouse like Snowflake, where a bunch of logic is like transformed so that people can now like any rank and file like field operator for the supply chain analyst team can ask about any truck, where it's headed at any given moment in time, view it on like a map in an internal tool, and then say, oh, let's reroute this to a different location because we've determined that like a different like allocation of resources will like help prevent us from losing as much money because there's like a hurricane that's about to impact some area, and like that'll hit like some of our distribution centers. So we want to like allocate resources differently. And so all of that kind of lives, all that is held together and lives on top of like the modern data stack, which is the ingest, storage, transformation, and then analytics.
It's a great explanation, Ethan. I think that even those that are not particularly in the technology architecture space can really understand the impact of it. And also you mentioned it, but congratulations on your post announcement on working with the NBA, the National Basketball Association. I think that many of us who are sports fans often wonder what is the value of data, particularly in advancing their technology in this space. Can you just talk a little bit more about really the benefits of what a National Basketball League would have with better data and better data analytics?
Yeah, in a lot of the places that we're starting, it's like much of like what like almost all companies have like this the marketing, like you have your customers, you have services or products that you provide. You have like some like event data about like interactions between these things, like subscription events, purchase events, cancellation events, stuff like that. And then you have like usage events, right? You have like things that like represent your like the way your customers interact with your usage. This could be like login events. This could be like liking something on Facebook. This could be like watching a video, like watching a stream of a basketball game that you're like really excited about. And so all of this information, like having really like building that digital twin of your like of what's happening in your org inside your data stack, then lets your marketing person sit down and be able to say, oh, can you show me like the list of users who subscribed in the past year, but haven't logged in the past 30 days, that we've determined is like a decent like potential churn risk. Let's like flag that and then send that into our marketing automation platform to then like send them like a win back or like a re-engagement type campaign. And that's something that right now, if you're a marketing analyst, you probably relate to this at a large corporation, but that's you have to submit a request. It might take a couple of weeks for that to get back to you. It might not be like over the dimensions that you care about or like break out like the way you want it to. And you're not actually sure like how they calculated, like not logged in, if that's like just for the application or it's the EU version of the application, whatever department you're in. And so now you're not certain. You ask another comment, the data person gets back to you like a couple hours later, but you're in a different meeting now and you've kind of like lost the context of that thread. I think like there's hundreds of thousands of like data-driven operations and decisions that should be getting made, and they just don't get made because the velocity of like the kind of like read, analyze, take action paradigm is like on the order of magnitude like weeks sometimes, depending on the organization. And so for us, really what we're trying to bring to the NBA is like the ability for every single operator on partnerships, on marketing, on sales, on product management, to be able to query like the entirety of your business data instantly, right? You don't need to go through, you don't need to bug the person on the data team who probably is trying to build like a massive machine learning model to forecast something. And they don't want to write like a very simple like SQL statement to get you like the report you're looking for. But like these reports are critical to your team, right? You're in a business meeting. Someone's like, oh, like what is your you're meeting a partner, and they say like, oh, what is your overlap with like our with our like viewership segments? And you're like, oh, that's a great question. Let me follow up and get back to you. Like that's like a really slow like turnaround cycle. It's like
Yeah.
really like this destroys your momentum. But instead, like you as like a strategy consultant or something can just pull up your screen. Actually, that's a great question. Let me just ask that right now. Get back to you. Oh yeah, it's about like a 73% overlap across like Northeast regions. Do you want to see that on a heat map? You like share it to the screen, and like you can instantly like make the point without needing. It's like a personal data scientist like at your right hand.
I think it's a great explanation, certainly reducing the time lag and certainly the friction is really important for increased efficiency. So I know in the past you've talked about the concept of connective tissue, and perhaps you can explain that concept to the audience today and how this connective tissue contributes to the effectiveness of large language models in processing and interpreting data.
Yeah. So earlier I kind of mentioned like once you bring data from like all your different sources, all the places where it's produced into like this like shared like giant warehouse, there's a little bit of like logic that your team kind of does on top. It's like just data modeling, data transformations, whatever you want to call it. Like hopefully there are like a bunch of different schools of thought, and your data engineering team is like turning it into, or analytics engineering team is turning it into tables that make sense for your business as a whole, right? There like some people transform it into like a very, very, very wide table. Some people put it into like different level. There's a bunch of like technical ways, but not all modeling formats are the same for the purpose of like teaching an LLM, right? Like you can architect a house like to for aesthetics, you can architect a house for like heights, you can architect a house for like cheap building material per unit of square foot. But if the metric that you're trying to evaluate yourself against is like the ability to withstand a tsunami, like there's a specific way that is like the best way to architect your house. And in the same way, there are a bunch of different ways you could model your data, but if the metric you care about is like the connective tissue, making sure like you have the rails, the train tracks in place for a language model to be able to operate across it with 100% accuracy, right? Because it's really important. Like you can't have like hallucinations when like people are trying to send out massive campaigns to like their users. In order to, if you're evaluating the way you build data models against your ability to, for a language model to read, I think we fallen on our face several times, like as we built this out. Like I think we built our platform like 6 times over now. But I think we have like found like a way of architecting your data models into what we call like an ontology. It just means that every single table corresponds to the like is named like a noun that your business operators relate to, right? There are no like fancy tables with like strange names that you couldn't explain to your kids, and sometimes you even forget how you would explain it to yourself sometimes because like the name's so unintuitive. Every single table name has to be intuitive, and using that like and deprecating a lot of the logic underneath. I won't dive into the technical details, but essentially it's a way of modeling data so that language models can consume it with 100% accuracy. Where when I say accuracy, I don't mean that if the data is not there, it can just pull magic out of thin air. But accuracy as in if the data is there, we can tell you with 100% certainty we got it. If we didn't get it, we can tell you with 100% certainty it's not there. And that creates like a really, really, really powerful feedback cycle with the data engineering team and the business side for so that on the data side, you know what your consumers want to ask questions about. And on the consumer side, like the business operator side, you know that your data team has curated like all this like incredible and like really, really valuable operational information for you to use.
So it certainly sounds like data plays a huge part for many organizations for this to be successful. But in terms of companies that are building large language models, in addition to the preparation of the data, what would you say are other key components that make for a successful rollout and scalability of their large language models?
I think one of the big things is like you need there's not a lot of overlap in expertise for like data architects, like traditional like data engineers, and like AI researchers, like people who are like experts with like building with large language models. The AI researcher segment is also like even thinner, because most people who are familiar with like building products with large language models tend to do it for consumer purposes. They like all live in SF. They don't really care too much about enterprise use cases, and like like they don't treat like security as a first class citizen. And so now like you're it's really, really, really important that you have a very, very tightly coupled or like set of three things. One is like the business use case represented. Second is the data architecture well understood of your local business, like the ways you define words like transaction or like retention rate. And then someone else who understands the trade-offs of like how you build with an LLM. If something like under what conditions will things hallucinate, under what conditions are things possible or not possible, or like what are LLMs good at, right? What are the use cases you can begin to overlook? And so ideally you'd be able to get your hands on someone who is simultaneously like cares about the business user, understands the data architecture, and understands the limitations of LLMs. That's like a really, really hard, like,
Very hard.
there are very, very few people in the world who like have that ability. And so otherwise, like your alternative is you need to bring in an expert on the LLM side, probably to like sit down with your business operator,
Yeah.
probably like working tightly and like potentially reporting to the business operator, and then like the data architect is like supporting on the side. And so that process is fairly challenging. Those are often going to be like very different personalities. And so you're obviously extra benefited by like having like a VP person overseeing this who has very, very good sense of how to leverage LLMs. And I'm not going to pretend like this is something that every single company can get access to. I imagine like for the most part, like enterprise grade LLM experts are, making millions of dollars at OpenAI, or Anthropic. And so we try to, at least like at TextQL, like we try to, bring people into your offices to do like on sites where like we have all of our engineers. We don't have salespeople. We don't have product managers. All of our engineers are also double up as like talking to the customers, caring about workflows and use cases. They were all like former data engineers in some ways, like they're like really strong database fundamentals. And then they've been building with language models for the past like year and a half since like the stuff has come out. And so we deploy our people to try to like fulfill all three of those roles together in the enterprise setting. And yeah, like it's hard to find those people. So we for the most part just kind of like hire ex-founders. So most of our team is like ex-founder, former CTO, like venture type people. I don't know if that's super. It's just like a really hard, like all three of those voices almost have to be represented. And then that's like a really hard like line to walk.
Yeah, and certainly many organizations are also not quite ready, or they are struggling with the talent, I think is a big piece of it. But also you mentioned earlier the concept of hallucinations, and I think that
Yeah.
people are now more familiar with that terminology used in terms of large language models and in terms of hallucinations, and certainly inaccuracies in terms of the results, the outputs of these models. But what do you think are ways that organizations can deal with the quality of data when they're modeling large language models, whether it's in the preparation of the data or how they train the
Yeah.
data? What quality assurance measures are important, or particularly important here?
Yeah. I guess there are probably like a few things I should just like, if I could like dispel the myths, it's probably worth doing. You don't need to fine tune LLMs on your company's local data. If anyone tells you that, they probably don't know a whole lot about LLMs. The way that 90% of like successful enterprise products that have been like deployed into like company environments is like way more oriented towards like RAG architectures than it is like towards fine tuning. Unless like there are very, 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 very specific situations where fine tuning is like the appropriate approach to train your like structured data in your data warehouse on an LLM. The other side is like being ready. Like probably like no one's ready, and people, but also like the nice part there is because like the metric has changed, right? The metric for like how well is your data modeled, what quality of your data is that, that's changed to now mean like the goal is to make it readable to LLMs because of like the 10 100x leverage that you get out of like using AI in your data to day. Everyone is equally not ready. Like so you also feel if you were like previously like falling behind like, in terms of like digital transformations or like innovative like initiatives in terms of bringing data in, now you are still behind, but you're also as behind as everyone else. Like the people who had a lead on you as an enterprise are like now at your level. And as long as you like modeled your data, like your future initiatives treat language models like a first class citizen, getting data quality to a point where LLMs can navigate it is a it's like a fairly well scoped problem. You don't have to. It doesn't require every single column to be perfect. It does like most enterprise data warehouses. We're dealing with 100 databases to 100 schemas to 100 tables to 100 columns. By the time you're like at the column level, like you're dealing with 100 million entries. No one's going to index that. It doesn't matter if you're Facebook. It doesn't matter if you're Google. Nobody's going to index 100 million entries for an LLM to like write like perfect SQL or like retrieve the perfect data back. And also like they have a million rows, so that's I think it's 100 quadrillion. We're dealing with an upper bound of 100 quadrillion actual like values. And so the way you end up like architecting is like you start with the business people. You start with your like sales manager, your marketing manager, your customer success operator, your supply chain operator. They don't know that there's 100 million rows of like or columns of data in their warehouse, but they go about their day perfectly fine, right? In their
Mhm.
minds, they have like 5 to like 25 like concepts or entities that they are regularly like asking questions about. And as long as you and they have a source of truth, right? They're able to do their jobs. It's not like they're falling apart because they don't know all 100 million things. And so really like you work from there backwards. You start with the things that they really care about and they like you index the things that you index the things that they care about such that the language model is able to navigate their workflow. Because if you can make that human like 100x more productive or like 10x more productive or 5x more productive, you're getting the value. Like you don't need to index everything in your warehouse to get things ready. And I think that's like a thing that a lot of practitioners or like data architects actually kind of miss, which is that you don't need everything. You don't need coverage on everything for you to deliver an immense amount of value. And also, value is like not evenly distributed. It follows like a very strong like power law where the first like 50 tables that you index are probably going to deliver like 95% of the value that you'll ever deliver with LLMs.
I think that's a great point. And I often hear that the biggest mistakes that architects make is really boiling the entire ocean, overscoping, or achieving 100% perfection when, as you said, there's a lot of efficiencies and benefits probably already in, the first 80% of the, of the coverage. So, but I also think you make another great point about really understanding what are the most critical business use cases to prioritize, as well as what data that aligns with in order to make sure that type
Yeah,
of efficiencies get met first. So I think seeing the value, the ROI, is always the biggest hurdle, I think, in terms of
yeah,
organizations getting on board and then continuing that investment. It's not a sprint. It's just probably
yeah.
a
It's like
longer
a
race.
marathon.
Yeah.
You start with something that we see is like we'll start with like the marketing team or like the product marketing team, let's say like even a smaller subsidiary. So we have like campaigns. We'll like model out like campaigns and products and users and usage like sessions, like people logging into the product and not logging in. And then when we satisfy like most of the use cases, when we turn around to the product management team or the other like the brand marketing team or the performance marketing team, we're not starting from scratch. We're reusing many of those same concepts that the product marketing team cares about for the product management team, right? And so like incrementally, like you can see how like the if you create a single vertical use case for one specific team, often like that's really just going to be determined by like which of your directors or VPs do you trust the most to like really make use of like new technology, and then you win the hearts and minds of those people. They rave about it to their neighboring departments. Those neighboring departments probably have like overlapping like business concepts for you to index. And so like that maturity starts and then grows within your organization out from like the focal point. And I think like marketing and product teams are fairly data driven, but also like supply chain teams I know are like some of the most like data driven ones out there, and manufacturing hubs. And then like obviously at financial services institutions, like traders, portfolio managers, these people are living in spreadsheets. They live in the numbers. And so often finding like the most maybe like finding like the second most data driven department where they don't get like all the resources that you get today, but they do clearly care about like making like investments in data and analytics. I think like that's often like a really good place to start. And then you just see like the maturity like grow throughout the organization from the ground up.
I think that's a fantastic example. I mean, certainly that's how the adoption or really the explosion of new technology gets started, finding the biggest pain points and having that team, adopt it, rave about it, and it certainly gets matured. So I know you talked about, specific examples of maturity, especially within either a marketing or a smaller team inside an organization, but within your customer base or what you've seen, and can you share some examples really successful, relatively successful real world applications where effective data modeling has significantly improved large language model performance?
Yeah, where modeling has improved the performance. I think for us, one of the guarantees, so like this idea that it's okay for you to sometimes return data that's not actually there, or like miss data that is there, that you should have been able to find, feels like a architectural like decision that I think a lot of data leaders like think that they have to accept because like, as a working in data infrastructure, you kind of like used to having to make these kind of trade-offs. I think like 100% transparency on every single thing you return is like table stakes for day one. And so depending on the way you model your data, if you start with like a couple like nouns, every single thing that somebody asks should like route to either one of those nouns, or it should route to the statement like the thing you asked about does not exist and we have not modeled it out yet. And I'm sorry, and like maybe come back like create a Jira ticket or something about like that. So like following that model, our architecture, I know that there are pretty sophisticated players out there that have like fine-tuned like massive amounts of compute on their own internal data warehouses. And the ceilings that they're starting to hit is like 55% text to SQL accuracy, right? Or like 60% on like a relatively like constrained set of like tables from like their overall like data warehouse. And these are just that's probably the ceiling of what you could do by throwing like 10-20 million dollars at the problem. um, Probably isn't good enough if like every other query that only like 60% of your queries even execute, and then of those like who knows how many of the things that it's like, how much of the data that's returning like has the right filters or understands the right like business context. It feels like we probably need a different approach. For us, like our accuracy, like the chances that we return something that like reflects the state of your data is 100%, but that's like by construction, right? Because when somebody asks a question, we first just try to figure out like what are they asking about. If it's there, we return it. If it's not there, we don't. And that's not we don't leave that decision up to a language model. We leave that decision up to like a fairly rigorous set of I guess like deterministic. I could just call them if else statements. That probably be accurate. We just put them down those two paths, and our classification is like a much more. There's a lot of like traditional data science concepts that don't require language models, and really help you like put the guardrails on around the LLMs, right? If you think about it, like how hard it is to build like full autonomous driving for cars in the streets, because you can like make small turns, make small adjustments. Like there's a bunch of different like road signs. There is like a form of transportation that has like full self-driving, and it's had that for a very long time, and it like very rarely crashes, and it's trains. Like if I told you like bullet trains like travel like much faster than cars and they traverse that distance like fully autonomously, like you wouldn't blink an eye because like you put them on tracks. And you don't need to make nearly as many decisions as a result of that. That's kind of like what our like data modeling architecture does for our enterprise customers. Probably we don't have like case studies that we've like made public yet, so probably can't like share immediately. Like the examples from our existing customers of like improvements from like before. But often like we're also coming in where they haven't run a ton of LLM experience, and they're like, entrusting us with a great deal of trust to like be the tip of the spear for them, to like explore how we can like use large language models within their organization.
Yeah, that's great. And I actually, when you explain the fact that bullet trains run at hyper speeds on railroad on tracks, makes complete sense as to why it can go so fast compared to why cars on the street can't do the same. So I think that's a great analogy, and hopefully those in the audience can read more about your use cases when it's public and published. But just looking ahead in the future, just maybe an upcoming year or so, what do you think are the biggest challenges that you see in the industry that you think that TextQL can solve and be primed for?
I think right now there's a big push for people to decentralize their data from like warehouses into like larger like storage environments to switch to like a more streaming data architecture or essentially like all of your data is like kept up to date like on a per second basis instead of like a per 4 hour basis and you know more accessible. Like there's a convergence where data that like exists in your applications is like basically the same data that exists in your like you know like large storage environments. And in that world, you know, one of the most painful things, like one of the biggest challenges we face is like the idea that like you know data we retrieved might not be like fresh relative to like the data that you have because we're connected to the storage and not to the live data. And so as people like see their storage become more and more real time, I think like they're gonna have a ton of like operational like every single day like questions that your supply chain analyst, your marketing analyst, your sales operators like are going to ask, like, oh, for this account, I'm like I have this like meeting coming up. Show me like how much they use our products. Show me like if they're likely like what do you think what is the sentiment analysis on like all the things that they've said? Putting these incredible like data science powers into the hands of like every single day business users who have the business context. I wish I had a specific vertical I could like just like you know push really hard on. But the truth is like we're really excited about like every single like team that's out there. So like any company that has like the is like interested in investing in this and like might like struggle with like finding the talent for people to build like super custom vertical like solutions with LLMs. I just yeah we work I would love to hear from you or talk to your, you know how it goes.
Exactly. Reach out to and connect with you. So that's fantastic. I think that there's just a lot of excitement in this area for, organizations, depending on their maturity level, to certainly talking about exploring it, advancing it, and definitely finding a lot of benefits for it. Do you also think about some of the regulations that are certainly being proposed or already in place in either in the EU or as well as the United States, what that effect would have on accelerating your business as well?
Yeah, I don't think I know a ton. I tried to give caveats where I'm not like I'm very, very unqualified to speak on like legal regulation in terms of like copyright law or any of that stuff. I will say that like when we work with like enterprises in the EU, we find more stringent like security protocols that we have to adhere to. You know, we had to like pause a little bit to make sure all of our deployments were GDPR compliant in that area for people who wanted to explore in that region. It doesn't seem to hold us back too much. And you know, I imagine most use cases are probably going to be a strictly like simpler use case than like what we typically deploy since we are a little bit more enterprise grade and like designed for that complexity. So yeah, it doesn't seem like any of the regulations is holding back anything I've seen so far. But also that could just be because like they haven't hit the books yet. And I sorry, I don't know anything about like what's going on in the courts right now and like the like litigation around like rights and copyright and like training data and like what your people are allowed to expose or not expose. We just live and die by the regulations and rules that the legal team at our customers like give us, which is often don't send PII data to the large language models, which is probably fair, or like only send schema information to them, so it's like only metadata as opposed to like strict like values from your like data warehouse itself, which is also probably fair. Yeah.
No, I was going to say that oftentimes this is when technology companies can help your customers be compliant just because
Yeah.
everything is probably more automated and audited and documented for that purpose as well. So Ethan, I can't believe that our time on this podcast is almost up. I mean, had a really fascinating, interesting discussion with you. Just want to leave any additional comments that you want to share that we haven't covered so far, thoughts about the future and the direction for TextQL could be your closing remarks.
Sure. I think this is like super exciting. There's a lot of like, as is the case, I imagine, with like all prior waves of technology. There's a lot of use cases that are like not particularly inspired. And I think like there's a lot of like education that still needs to be done. Like the LLMs have essentially come out of a community that has historically never really cared about like marketing. Like there's no like real big spokesperson for like AI in the enterprise, like who's like championing the development. Where I think on the other side, like I don't know, with like cloud or otherwise, like there were like very large, like AWS or like Azure were like big champions of like how to use this. I think AI has been like very much thrown out there with not a ton of LLMs have been thrown out there with not a ton of like guidance. Because it's not like S3 or like EC2, like storage, compute, very simple concepts previously existed in real life, now exist in the cloud. Wow, like everyone can plug in. That makes sense. LLMs are like a totally different kind of paradigm, and like people are still like slowly learning. I think we went to a data conference the other day, and we kind of found that like the like literacy rates on what kind of use cases are like totally impossible and people are entertaining it, and other use cases that are like incredibly easy and trivial and people are like scared to attempt it, is like very high. And so like yeah, for us, probably something we should also be able to do better, is like we need to educate people, and like share with them like these are the things that we can incredibly safely do that will like deliver a ton of value. And in order to make sure that we don't sound like everyone who's describing it like it's actual just black magic, these are the things that we just can't do. And like this is just not what like LLMs are good for. To be like super transparent about like what can be done and what can't be done. So we're, I guess, somewhat trustworthy, is what I'd hope we can position ourselves as.
That's fantastic. Thanks so much, Ethan. And certainly this podcast will certainly provide some of that data literacy, that education, I think that everyone is craving for and really needs. So I think getting everyone to understand all these complex concepts is really key and important to making sure that they're doing the right thing in their day-to-day role as well.
Yeah, for sure. Well, thanks for having me, Peggy. And I wish you the best today, or best, have a great day.
Great day. Thanks so much, Ethan, and have a great day as well. And for those in the audience, thank you for listening to another episode of BetterTech. See you next time.